So you made it. It's the morning session. I hope last night was fun. Everyone have some fun? I actually got in pretty late. I'm from Michigan, so it took a while to get down here. The Detroit airport was a mess, but I made it with my wife. We're very happy. We're just a little tired. So I haven't enjoyed too much yet, but I'm very much looking forward to that tonight. So the talk today is high availability with Azure PaaS for websites. And I'll tell you all why that's something that I'm pretty passionate about in a second. But I'm also very curious whenever I do a session like this of the audience and kind of your experience. So I like to start with a little hand raise exercise. How many people in the room use Azure? Cool, about half. AWS, other half? Any Google Cloud? Like one, maybe. I'd be in that maybe category too.
We had two once.
Yeah, yeah.
We don't talk about
All
it.
right. How many people in the room are developers? Okay, almost everybody. Cool. So this should make a lot of sense. Any pure DevOps people? Okay, a couple. I'll try my best for you guys. Any project managers? Sweet. We can totally talk about project managers today. So thanks for coming. My name is Brian McKeiver. I am co-owner at BizStream. We're a digital agency in Grand Rapids, Michigan. Anyone been Grand Rapids, Michigan? Okay, the one guy, I know you're my friend, so it doesn't count. So no one. So I tell everyone this as I travel and speak around the country. Fantastic place to visit in the summer. Like right now, it's beautiful. It's almost as nice as here, minus the humidity. So it's warm. It's hit like 90 this week, which is a little rare for us. However, in the winter, do not come, okay? Snow, cold, dark. It's miserable, and that's why people from Michigan really enjoy coming to Florida. So thank you for having me down here. So my company has been in business for 21 years. Actually, this year we're having our 21st birthday party and next month because we'll be old enough to drink at that point. So we did not celebrate 20, we're celebrating 21st. COVID maybe had something to do with that planning as well. But we build websites for people around the country, actually further away than that as well. But they're usually large, heavy websites, e-commerce, CRM integrations, ERP integrations, big time portals for customers and dealers and all sorts of fancy stuff. And the way I summarize that is they're just not really like mom and pop shops. But to do that, we don't roll them from scratch. We use platforms. Some of them are CMSs that are traditional CMS where there's a database involved and a code base that you get. Others are headless CMS where it's more API first and SaaS-based solutions. So we're kind of spreading our wings. But for the 20 years, we've been a Microsoft.NET shop. So we've always done .NET since it was classic ASP. Any classic ASPers in the room? Okay, a couple. I'm showing my age a little bit. But now we're using .NET 6 and some of the .NET 7 stuff, hopefully soon. And we've always kind of done that in Azure. And that's why I like to ask the question of who's it. Like years ago, we did some AWS. It was great, but it's really not much different than doing full on-premise IaaS. And I'm here to say today that Azure has some great tools where you can forget about IaaS, and we're going to use platform as a service to kind of publish our websites to and have high availability, high performance, scalability, all the promise of the cloud. And that's what Azure can do, and I'm a big fan of it. And for that, I actually forgot to mention, I'm actually a Microsoft Azure MVP, and this is my sort of specialty, is Azure App Services and PaaS-based resources. And I'm also an MVP on two CMS platforms. Kentico Experience is a traditional one. It's a lot like Sitecore or Sitefinity or even WordPress. Anyone have heard of those CMS platforms? Okay, a couple. And then the one that we're going to talk a little bit more about today is Content AI. It's a headless CMS. Has anyone used a headless CMS on a project? Well, fantastic. Minus the guy in the back. We're going to learn some new things today. All right. So yeah, we covered that. This is Azure. The reason I'm here today is to tell you that uptime matters. And I don't know if you've all been involved in a situation like this, but you may be at a conference, you may be at home, you may be on a golf course, and you get that dreaded call, right? The website is down. Oh my God, what the heck am I gonna do? I gotta find a computer. I gotta talk to this person, that person. We gotta pull in the customer. We've got customers calling us. The support people are angry. When things go down, it's expensive. And this is a stat according to Gartner that's $5,600 per minute or almost like $300,000 an hour, right? I think that's a little inflated, to be honest, but Gartner likes throwing out big numbers, in case you don't know. And it was their number, not mine. But the point is still true. It's very expensive because we've got to get a lot of people involved. And it's the cost of their time. It's the cost of maybe firing up a new server. and moving things, it's super expensive. So if we can avoid downtimes, we're usually in a good spot, right? Our customers are usually happy, our business stakeholders are happier, heck, even the developers are happy because they're on the golf course, not taking that support call, right? So uptime matters. And that's kind of the premise of the talk. I like to start with what not to do when moving to Azure. Because this is very, it's out there, it's this thing called a virtual machine, and there's these tools where you can just migrate to it really easily, and all it does is really kind of pick up your on-premise IaaS and move it to Azure, and that can be a good option. There are a couple reasons why still having a full virtual machine is great, and I'm kind of curious, I forgot to ask this question earlier, how many people in the room actually use IaaS or full virtual machines to do their Azure workloads? Okay, a couple. Great. How many people in the room use platform as a service or like Azure App Services, Logic Apps, serverless? Great. More. A couple of you just aren't sure yet based off the earlier feedback. That's fine. We'll figure that out during the talk. But there are two things that I like to tell people what not to do, especially when I'm telling to our business customers and helping them transition to the cloud, is one, to treat it like the old way of doing things. And what I mean by the old way is, I'll tell you a little story. So we run a product at BizStream as well as our consultancy. And it's a very niche thing, but it's always had to have a load balancer involved because it's a government app and it has to be highly available. So reverse 20 years ago when we first started this, we had a couple front-end web servers, 2 database primary, secondary sort of failover things, and then this thing called a software load balancer that Windows used to have that came with it. Does anybody have experience with the software load balancer? Couple. Yeah, it was a pain. It promised the world, oh yeah, sure, you can have one server up and then drain stop all the traffic, and then the next one will work. But you know what? We had more issues and challenges from that stupid software load balancer than our app did, because we wanted to patch and maintain one server while the other server in the farm was still running. It was just kind of a disaster. And some of that technique can still be done in Azure, in IaaS, but I'm here to tell you there's a better way. So don't treat it as like the old world. Don't think of it, I'm just going to put a load balancer in front of my stuff and it'll be highly available at a click of a button. There's just a little bit better way, and we'll cover how to do that. And the second thing is really just, I gave it away already, but don't just simply move your IaaS as a virtual machine. There are lots of other technologies in the PaaS world that can make it very easy to accomplish scalability, performance, and high availability. And we're going to cover those today. So no virtual machines, death to virtual machines is the thing you can take away from the talk. And I think Azure PaaS is the answer to that. There are a lot of things out there to do that. So we're going to cover a couple. But before we cover the specifics, just a couple benefits. And I won't read everything on the slide because a lot of you are using this already. But in case some of this is new, the main thing I like to recommend PaaS is no maintenance of Windows servers. That's like the number one huge thing that we have just taken out of the equation and Microsoft kind of handles for us in the Azure cloud, right? Number two is scalability and performance at a click of a button, and I'll show you how to do some of that today. And then obviously there's some price save generally when you think about the full licensing cost of running your own machines versus using Azure PaaS. That's the highlight of this. And the other thing is there's just some developer tooling that the workflow of deployments, it's easier, it's better, it's faster, it more tightly integrates with things like CI/CD pipelines. It's fantastic. So really, when you're moving to Azure, think of it like this. This is, as opposed to that first picture with the CRT monitor and the old school way of doing things, this is roughly a picture of one of the containers that the Azure world sits in, and your app can be in one of these blades or boxes, and the platform can move it around to other places, and you might not even know. If there's a problem here, you don't have to worry about it. If there's a problem in your data center, you have to take that phone call on the golf course, right? Not a lot of fun. Also, I just think this is a cool picture. That's a lot of server power in there. So, Azure App Services are the first tool in the toolbox of deploying PaaS. How many people in the room actually use Azure App Services? Fantastic, almost half of you. This is great. So one of my favorite things, and this is the meat of the talk, because I believe app services are still the best way to host, deploy, and publish a .NET-based website. And a couple other technologies can fall into that too, right? It does Python, it does a couple other things. But for today's purposes, we're going to talk mostly about .NET apps and how they run. To do that, I like to start with building blocks. This is the first building block of Azure App Services for a standard .NET-based website. And in fact, if we apply that to my scenario, where I always have a content management system or an e-commerce platform tied to the website solution, that's why I have 2 app services inside of the plan. Those 2 app services are our code bases. That's where the URLs actually get served out of, and they usually connect to an Azure SQL database. And all of this is PaaS offerings. So I'm not talking about a full SQL server, I'm talking about Azure SQL Server in a SQL database. You can provision each of these resources in the boxes inside of a resource group, and that is the #1 building block. This would host and run a very high-performant .NET website. And you know, it's whether you have an admin tool, which is why the App Service 2 is in my picture, and that's where your marketing team could log in and like change content and publish pages, versus the live website of like www.website.com would be in App Service 1. Does that make sense? Because this is the building block for the rest of the talk, okay? Does anyone use a similar architecture like this in their projects? Cool, a couple of you, good. By the way, keep them in the same resource group as best as you can. The tighter you keep them close to a resource group and in the same region, the faster the performance is. I see some people split resources across regions with just like no rhyme or reason, and that's one thing you don't want to do. Now, the next level of that, because the solution I just showed you is great if you have one instance of those app services. But what if you need to scale and you need to handle more performance? That's where the scalability factor of Azure App Services come into play. And you might have multiple instances of your websites, but to do that, there are some other tools that you need to like hook up to the solution to make it fully scalable. And that's why I've kind of taken the first building block, moved it up, and I've introduced some new resources at the bottom. And one of the first things that you need to do is worry about files. So most website projects have large images, PDFs, MP3s. I hope to God they don't have any movie files or AutoCAD drawings in them, but sometimes they do. And a lot of the websites we work with have tens of gigabytes of image files that they serve out for thousands of pages. One of the things about app services is there's actually a file system limit of the file system in the app service. So to make it scalable, we recommend adding external storage through the Azure storage of a blob storage provider. Most high-end CMSs or even the .NET SDKs allow you to pull out file storage and abstract it into an external storage account. And does anybody want to guess why we might want to have those file systems in a scaling solution into one place? Anybody want to guess the challenge that solves by doing that? All right, we're all shot. Okay, in the back.
Deployments, so we're deploying App Service 1, and price in general, if we have files on App Service 1 and App Service 2, we may have duplicates or not duplicates.
Exactly. Exactly. That is a perfect answer. You don't want to duplicate tens of gigabytes of files on a server storage space alone, let alone your deployment pipeline trying to move those files to multiple times, right? So if you extract them and move them out, you have one solid place that has its own backup and highly available tooling, because you can replicate blob storage to 2 regions with basically a click of a few buttons. And now your app is purely the code. So deployments are faster and you reduce duplication by pulling that out. And again, most high-end platforms have a way to do that through some very quick configuration. Or if you're rolling your own app from scratch, very easy to use the Azure SDKs to do that as well. It really just abstracts the file system code to point externally. The next thing you need to do is worry about session. So if you have multiple scaling sites, multiple instances of your app service, and say you're an e-commerce shop, you don't want sessions to bounce around between those instances, so you need to handle session state somehow. And that's where Azure Redis Cache comes into play. It's tempting to go old school again, and how many of us have used SQL Server for session state management providers? A couple. Azure Redis is today's answer to that. It's faster, it's cheaper, and it works really, really well to make session state management. There's a NuGet package and like one line of config in your app settings or in your web config, and you can handle session state, again, into one resource that you can scale on its own needs, or you could replicate if you need to. But that starts making it so that these instances, no matter if you have 1, 2, 3, or 4 instances of your app running, all the session is in one place, and you don't have any sessions that are lost. Like, you don't want someone to hit a shopping cart, put a product in there, and then their next request, oh wait, the shopping cart's empty. That fixes that problem. It keeps session all in one place when you're highly available and spread out across different regions possibly. Okay? I forgot. So I have the details of the storage. This is what the storage provider looks like. You may have folders or blobs, depending on how you would think of it. And it basically pulls that out of the files become like a JSON file or whatever, image file, whatever, become part of the container. So just some of the details on that when we go back to the files. If you haven't done this before, one tip I have for you all is Azure Storage Explorer. Fantastic free tool. It's basically something that you can quick download and you can interact with your storage on your desktop. No problem. It's super easy. And it's probably the best tool out there to work with those things. Because sometimes you have to like maybe copy those files down to your local machine in dev to see what's going on with the image that's not being served out or something. So I use this tool all the time and highly recommend it. Now once we have those things set up, we have session state implemented, we have the files outside, and maybe we even have some app insights enabled. This is what it looks like to scale a solution in app services. And there are two ways to do it. There's a manual scale and an auto scale, but simply by sliding the toggle or the slider, whatever we want to call that, over, you can control how many instances, and that immediately gives you that more performance. But you don't want to do this if you haven't set up those other two things first, right? The other thing that you can do is use the auto scale. So if you have unplanned peak traffic demands, you can set thresholds of this much CPU or this much RAM usage or this much requests over time, and that thing can auto scale for you, which is a nice little benefit that IaaS can't do, and that's a huge driver of using Azure App Services. So basically you get double the horsepower. Now there's some more cost if you're doing this, so you have to watch out, you have to be a little careful. You don't want to let it go to 99 instances, although I don't think you can go to 99. I think there's a cap based off your pricing tier. But has anyone scaled like this in their, okay, cool, a couple people. So I'm staying a little high level on that because there's more interesting things to cover. The other thing I had in the building blocks was application insights. This is a free telemetry monitoring tool, and it's like you're crazy if you're not using it, to be honest. It does a very good job of researching what's going on with your app. You can watch errors, you can watch performance. There's ways to even like dynamically add it to your app. It's super easy, highly recommended if you aren't doing that with this type of solution. Definitely would want to do best application insights. And then the last part of just the basic scalability tenets is use Key Vault. Don't have your secrets in your code base. You might, if you're scaling and deploying to multiple regions, you don't want to have to duplicate that stuff. Key Vault is a great way to do that. And if you're not, I'm sure we could probably even talk for a whole hour about Key Vault in a separate talk, but I'm going to keep going because this is what I want to get to. All of that was, so building block 1 was the basics. Building block 2 was scaling and making it highly performant, but we're not highly available yet. Because if one of those things goes down and we only have one instance, we're still down. So the rest of the talk is now about making it highly available. And the way we do that is we have to have something that kind of captures all of our incoming traffic, right? In the first building block, the app service is what you would have your www website directly lined up to. You'd point your DNS at the Azure App Service IP that they give you, and all your traffic will be handled there. But again, if that thing goes down and all your traffic's going there, you've got a problem. So we basically need a door to capture all of the incoming traffic and help us quarterback where it's going. And Azure's answer to that is Azure Front Door. This resource allows you to handle the domain traffic coming in all at one place and then set up what are called backend pools. And a backend pool can be one resource or a collection of resources like we just walked through in building block 2. And this thing is a sort of traffic management tool. It's kind of a web application firewall because you can have security rules attached to it. And it's sort of a, you know, it's your first line of defense with handling availability. So to enable Front Door on top of the Azure App Services, we need to do a couple more things. And that is taking to building blocks number 3 is what I'm kind of showing here. So whenever you're using Azure Front Door, the way you really accomplish availability is by using multiple regions in Azure. So everything I've shown you, we were assuming that you deployed that to one region. Now, what I'm suggesting is you are going to copy the resource setup that you have. You're going to take your architecture from, say, East US 2, and you're going to duplicate that into region B at maybe Central US. Or you might talk to your business, where are your customers at? You might want to have other different regions. But basically, you need at least 2 regions. You can have more than 2. And you attach Azure Front Door to each of the backend pools. So at the top, I have my primary backend pool, and I have a secondary backend pool at the bottom. And what you do is you can route with Front Door. 100% of the traffic all the time should go to primary. That's where the majority of the work is going to happen. And then if there's a problem with primary, we're going to fail over, and we're going to redirect all the traffic to the secondary in central. So basically, if east goes down, within milliseconds, you could actually have central up and running. Now, that's a beautiful story to tell. But in the real world, does anybody want to guess, there's still one sort of gotcha even in this scenario, one sort of pain point that no matter how advanced we get, it's going to still be a pain point in the back.
Latency issue?
Sort of, so latency issue, not exactly where I was going, but yes, that is something to think about in this equation. It's this little gray line that says replication down from the SQL database. So most .NET apps have a SQL database involved in them, and I don't care if you've been doing this for 2 months, 2 years, or 20 years, SQL replication is a pain in the ass, okay? There's a promise that, oh yeah, we'll just enable replication. Everything's going to be fine in disaster recovery or failover scenarios. And in my experience, I want to punch the person who made that promise in the face because it never just works. You still need to handle the database replication. And in Azure SQL, that is much better today. There's more advanced ways to reduce the workload of the developer or the DevOps person who's in charge of this. But it can still hiccup and it can still fail. So I may promise that this is super easy and great, but please still have a good backup and maintenance plan on all of your databases, because in a failover scenario and high availability, sometimes all the tooling in the world isn't going to solve it, and you actually still need to restore from a backup copy of a database. That hasn't changed in 20 years, and I don't think it's going to change in the next 20 years either. That's just databases. So that is a very deceiving, faint little gray line that runs from that replication. But you still need to handle that. But basically, this is kind of, the secondary is like your cold copy in a way. And with things like log shipping or replication, you can keep the database up to date. And when you're doing deployments of your code, you do need to deploy to both places to keep them both up to date for all the apps in the app services. But this kind of handles the majority of becoming highly available in Azure PaaS. But I'm also leaving out one detail on this architecture is that how in the world is Front Door that smart? How would it know if your app is not performing well, if it's degrading in performance or if it's failing? Does anybody want to guess, or does anyone know what is missing in the equation for Azure Front Door being so smart and so great? Okay. Sorry, heard it? Maybe? One more time? Well, health checks is the answer. So, sorry if that's just said it, maybe. Basically, my statement was wrong. It's not smart at all. In fact, it's stupid. You have to tell it that your app is performing and available and up. And you do that through health checks. So this is kind of a part of the equation you have to add into your application logic and level to tell the Front Door resource that things are working and things are available. And it's actually a NuGet package. So you install this NuGet package if you're working in .NET Core, .NET Standard, or .NET 6. There may be a couple flavors of it because this screenshot might be slightly old. But basically, if you install this package and you run a route of /health, and you can configure that, but this is the default one, it's going to respond healthy over and over and over as long as your app is up and running. And you can customize the health check to make it like check your database. You can have multiple health checks, but the basic health check is like a heartbeat. And what happens is that Azure Front Door is probing your backend pool over and over and over. In fact, it's incredibly rapid. It's multiple times a second to make sure that your sites are up and running when those health checks respond. So if you don't have those things, it's not gonna work all that great. But you also need to make sure that when you have the health check enabled, that you're aware that your app is going to be hit over and over and over. Because if somebody tries to apply like analytics to this page, suddenly it looks like you have a ton more traffic than you actually have. It's actually just the front door probes making sure things are healthy. So this is definitely like a secret route you don't want your marketing team to know about by any means. Okay? When you have this solution, you've achieved high availability, right? You're splitting your resources out across central and east. You have scalability. You have that sort of performance option and the quarterback featuring of all the traffic manager. This is one really good way to do it, but it's not the only way. But before I move on to some of the other options, does this make sense? Any questions? I want to make sure. Okay, I got a couple nodding heads. Good. All right. I'm a big fan of this approach, by the way. It's worked really well for us. Question.
Using front doors, any concern with anything like cores or anything along those lines?
Anything like cores?
Like cores, that concerns around that?
So not really, because that kind of, well, yes, there is one thing that we've run into. Because all your requests are routing through front door, sometimes things like if you're using WebSockets, SignalR, asynchronous requests through like React or jQuery or whatever, sometimes they have issues getting through and you have to add some configuration to the front door. So yeah, I definitely would test all of your not just standard HTTP requests to make sure they're working. I'd also look at if you're using any of those advanced things, especially WebSockets. We've had issues with WebSockets being able to get through them. And I think the answer was just more configuration in front door to allow it to happen. But great question. Yep.
Does your secondary failover setup here, does that basically double your Azure bill?
It does. It does. Yep. You're paying for each one of these resources. Yep. Yep. Hey, high availability isn't cheap. That's the other thing I tell my clients. Everybody asks for 99.99999% uptime, right? And then we give them the projected cost, and they go, "Ooh, yeah. Can we bring it in a little bit? Can we simplify it?"
So as a consultant, what I do is I give them that, and I say, here's the cost of that extra downtime, because 99.95 is like 6 minutes a year that you're down or something.
Yeah.
It's really, really small. Usually they see the difference, like, oh, yeah.
Yep. That's a great. Yeah. Yep.
All right, for that health check URL,
Yeah.
is it possible to only make that internal? Because it seemed like someone could potentially do us.
Yes, you can. You can kind of lock it. And that's another thing that front door can do is it can actually protect routes and things like that. So you can also do that with the app service itself and some routing config. So a couple options there, but good question.
Kind of off the back of that, with obviously a lot of the advantages that come from this are around scalability.
Mm-hmm.
Is there a small scale at which you wouldn't recommend Azure? Is it overkill for scale?
So is there a smaller scale that I'd recommend maybe a different solution?
Yeah.
Yes. For medium and lower website tiers, I would recommend Building Block 1 because Azure by itself has a pretty good uptime record. And Building Block 1, we have some medium level customers that's all they have. They have one copy, one instance set, one app service, one SQL database, and even they don't even do external storage. That works great for sites that are probably, I'll define medium as 50,000 page views or sessions a month or less is medium. The solution for this, we're talking these guys get millions of hits a month on their sites. So big time sites. That's where they're paying for this. But yeah, most sites, frankly, don't need this, to be honest. But sometimes you run across the big challenges that do. But I still think Azure App Services and Azure SQL is a solve for almost, well, I'll say half of small to medium projects. And the other things I'm going to show are some newer answers that are even cheaper and more cost effective. I think there's one more question. Okay, we'll keep going, but good question. All right. So everything I showed you was my knowledge of going through real world examples with some clients up to this point. And then Azure innovated and did even better. So now, as of like 6 or 8 months ago, they added the availability to do zone redundancy for app service plans when you start your app service plan. And remember, the app service plan is your pricing tier. That's the amount of horsepower you're paying for, like your standard, premium, P2, V2, whatever the next letters are in the alphabet. But you can actually do what I just did manually with a click of a button, and you can say, I want to enable my app service plan to deploy to multiple regions. This is somewhat newer, so I don't have personal experience with this method as much as the other method. And one of the other things is this requires a premium tier, which is a pretty costly starting point for a lot of apps. So to the earlier point, the things I've showed you, you could do with standard tiers or basic or free if you want to. This one starts at a premium, which is going to be, let's just say, expensive as a starting point. So it will work almost the same. You still have to think about your SQL replication in that scenario, but this is another option to be aware of, that if you want to, you can actually enable zone redundancy kind of out of the box with your first deployment. And you don't have to go through so much manual setup. But I don't have as much personal experience with this, so I just left this to be something to think about if you're in that premium tier.
That's still single region, right?
I think you can go across regions with the,
I believe, I could be wrong, but I believe when you have zone redundancy, it is two different data centers in the same region.
It's
Okay.
like an AZ equivalent.
It's like
Yes.
East 1 and East 2. It's
Okay.
Like it's redundant in a region, I think.
I mean, I can see there the region is still, you're still selecting a single region. So
right,
you're not
yes, correct. You guys are totally right. Yeah, thank you for the correction.
Infrastructure question.
Yeah. All right. So this. Oh, the other thing about that, the auto zone redundancy is you actually have a minimum of 3 instances as well. So that's another negative. So now we're talking premium times 3. That's a pretty high spend for that project, right? You better be enterprise level to need something like that. Which is why I also don't use it as much. I like not having to have 3 instances plus the availability. Okay. All of that was Azure App Services. Fantastic way to do things. I want to introduce 3 other ways that PaaS offerings help in the availability scenario. And we're talking about app service environments, container apps, and static web apps. So app service environments, or ACE, V3, there's also V2, but V3 would be the only one that you would use today, have this idea of an isolated infrastructure for your app services. So in the middle, the building block in the middle, it's still the same. App services with an app service plan. But what an app service environment does is wrap that up and actually give you full control over the isolated environment from like a networking, security, and compliance perspective. So if you have maybe a HIPAA app that tracks patient data or sensitive data somewhere, this is an option that works because it's not in the multi-tenant app service environments that standard app services and app service plans are in. This is, you literally don't even get an internet connection out of the box. You have to configure your virtual network so you can tie it to like your internal network and set up your what can get in from an outside perspective. Very, very top end, you know, and especially if you're in that need for security, compliance, and just isolated environments. And this one has automatic region failover built into it, not in the portal yet, but in the template that you would spin up. So you'd have to actually use a template to create the ACE. But right here, the zones are 2, and the instances, you know what? Maybe it's the internal load balancing mode 3. But basically, you need to have 3 instances of the ACE to have the automatic failover as well. And again, this one, I don't have personal experience in this one as much as the other things I've talked about. So link at the bottom of the slide if you want to find out more to this. I have one client who wants to start using this, but even then they're sort of afraid of the cost and the difference of the requirements that they'd have to handle for it. So I'm not as excited about this option, but I did want to point it out that this is another tool if you are in that world, especially if you're like healthcare or government. What I'm more excited about are things like this. Azure Container Apps. So this is a brand new thing that's come out as of build this year. Has anyone heard of Azure Container Apps? Awesome. Does anyone use Azure Container Apps? Okay, a couple people are maybes. Does anyone love working with containers? Okay, a couple. Sorry, I think containers are completely hype and overblown for most real-world things that are in the majority of the projects that I work on. I'm not a big fan of them. However, I like this because what the promise of Azure Container Apps is it handles basically containers for you. It's serverless, and the orchestration of them, all the crazy Kubernetes stuff and all the other low-level things to make containers work, Azure just handles for you. So as long as you have your image and your what you want to put in a container, it just makes that happen. We could do an entire talk just on this one thing, but there's not enough time for that, number one. But number two, this would be a fantastic way to not have to worry about a lot of the infrastructure of what we've talked about by using this service. So I would definitely recommend checking it out if you're in that world at all. But again, it's pretty darn new. I'm also very excited about Azure Static Web Apps. Anyone in the room heard of Azure Static Web Apps? Awesome. People in the room use it? Okay. Cool with us. All right. This, frankly, has me very, very excited. Azure Static Web Apps connect to your GitHub repo and automatically will deploy to a static web app in Azure. And it's meant to handle things like Blazor, WebAssembly, Angular, React, spas, any kind of pure static site build that you're doing. It's really good for this. And does anyone work in that space? Anyone in the Jamstack space or the Blazor WebAssembly space? Okay, not really. Well, basically the difference here is there is no database. You are basically building your project at build time through various things like a static site generator, and static is one of them. So at build time, your project builds, fetches resources, generates every single HTML page possible, and it could be 10 pages, it could be 1,000 pages, into your GitHub repo in a folder usually called like output or something. And that set of static resources, it moves out into the cloud for you. And because it's all the work is done at build time, the huge benefit of this is speed. It's insanely fast to just render a static HTML page. And you can still make it dynamic, so don't let the word static fool you. I do a whole other talk on making static sites dynamic. But pulling it from a headless CMS, which is what static can do, or other things can do, that's the thing that can take I have a code base that doesn't have content in it, find me 100 pages of content in my CMS, retrieve it through an API, build it, and actually static can render it through a Razor view system, just like any other MVC site can, output it and push it automatically through CI/CD to the static web app, and you're basically running in the cloud. And there's like not much else to do that. And to kind of illustrate that better, I have a demo repo, if you're totally curious about it. This is all set up to pull to Azure Static Web Apps. It's a project, it's a C# project, just like any other project, but it does those things. It statically builds the site at build time and allows you to push it through a connection to DevOps. GitHub Actions pushes it to the Azure Static Web App automatically. When you provision the Azure Static Web App, you tell it what your GitHub repo is or your Azure DevOps repo, and it actually will build the GitHub Actions for you. It's like super simple. It's ridiculously easy, and it ultimately gives you a URL and an environment. And in fact, every single PR that you do becomes its own environment. So what I'm showing here is I did a PR to that repo, and it created automatically through GitHub Action a fully dynamic URL that you can hit on the outside world at East US 2.1, right there in the middle. The front end of the prefix of the URL is just random. It makes that for you. But every single PR becomes its own environment. You get a URL to it. You get configuration for it. And you can push those out and compare environments between the two solutions, because the Azure Static Web App resource is in charge of knowing where those PRs are coming from, all the different builds that you have, because in a static world, it's all about the build. The build at that time is your website. The next time you build, you might have changes. So it's an easy way to basically compare production versus that new staging site. I know I'm going through that kind of fast, but does that make sense, or did I lose anybody? Okay, less shaking heads. Let me show that actually. So here is that GitHub repo. And the number one thing it did when I provisioned it in Azure is it made this static web app CI/CD this pipeline for me, basically. And each time I do a commit, it's actually running a build to push it out to the static web app. So that is here. Oops, I wasn't supposed to show that slide. That's for future. And that makes this website appear, as long as the Wi-Fi is still working. So notice that we've got like that .1 because this is the production environment. And if I looked at the PR build, here's that East US 2. We have a difference in this content, right? So that's kind of the basic idea of you're pushing all your site to this thing. And that can be hooked up to a CDN. And it's globally distributed around the world. So it's fast at the edge is this is the promise.
Quick question, that call API button on there,
Yep.
did that actually call stuff that's still on the GitHub repo, or is that calling something else?
It calls a managed Azure function for you.
Okay.
So that's the other benefit of static web apps is they have managed Azure functions. You have your own API built in, or you can bring your own Azure functions or other serverless functions into it. But that call API button that demos that actually, and it will call the function. It actually retrieves content from my headless CMS and puts it on the screen. Is what that does. But it's fantastic. So it's super fast is the first benefit. It's on the enterprise edge, which is there's no great way to visualize this, but you can basically click a button that says deploy all of my images, HTML, JS globally, so highly available, and it does it for an amazing price. And I'm not sure anyone quite saw it when I flipped over to my browser, but the price of this significantly different than Azure App Services. Does anybody want to guess about how much this costs, or did anyone see it? So to do everything I just said, it's $9 a month in production. Azure App Services in the standard-ish tiers, we're talking hundreds of dollars a month, and then we add availability, scalability. You can spend thousands of dollars a month because you need to support all the full .NET runtime and all that stuff. There is no runtime in static web apps. It's literally the HTML that you have. And you can generate it ahead of time. It's incredibly fast, and it's $9 a month, plus possibly some bandwidth cost, but I don't think you're going to hit too much of that unless you're doing a high amount of things. I think that's pretty darn cool. And I'm a big fan of this. I've used this in 2 or 3 production projects. It works great. Our QA team loves that every time a build happens, they get their own environment to go play with. The managed Azure functions are a tool that you can use to make it dynamic. It's just fantastic. Okay. So I've talked a ton about high availability benefits. There are a couple things I didn't quite mention. When we look at Azure Front Door, it does have some smartness to it. It can be used for DDoS protection. We've talked about how it can do load balancing and routing. It can be that firewall and some health probes. But it's a pretty good tool. Question?
One thing so everyone knows, on Azure Front Door, you can also do SSL offload.
Yes.
Azure Front, so that improves your performance significantly.
Yep. Who likes dealing with SSL certs in the room? Yeah, nobody. I've asked that question 6 times to conferences this year. Not a single person across the US has ever raised their hand to yes to that. I hate dealing with SSL certs. It's one of like the banes of my existence. With app services, you get free SSL certs. With Azure Static Web Apps, free SSL certs. I love the PaaS can handle that for you. You basically just verify who you are, and there it is. It's your SSL cert just working, and it keeps it renewed. Love it. Performance and scalability, we've talked quite a bit. Reduced maintenance, again, we're not patching servers. We're not running .NET Framework updates that come out every other Tuesday. Sorry, Microsoft people in the room. It's just a good way to do it. I didn't even really get into one of the other huge benefits of app services, and we might have time to do that, which is deployment slots. This is something that IaaS has no ability to do. So who in the room is kind of familiar with deployment slots? Great, most of us. You can actually use this to kind of do a A/B deployment where you can deploy to a slot or an instance of your app in the one app service building block, and you can test it because it gets its own private URL, and if things are working well, you can just swap it into production, and it swaps the production slot back to your stage slot, and suddenly you have a deployment that you're pretty confident in, and it basically was almost zero downtime, depending on your database configuration, of course. But removing the fear from deployments is a big thing for us. We like to deploy often. We still do have the no deployments on Friday before a holiday rule at Bitstream. Funny enough, that actually happened on the 4th of July this year. I kid you not. One of our largest clients rolled out a big Azure Search Index change the Friday of the 4th of July weekend, and it didn't work. And I got the call because I was the only one left in the company that wasn't like in Florida or some other place. So I got a call, and I'm going to tangent a little bit to tell this story because I just can't believe it. I got a call. The website's broken. They're in Azure. We're checking all sorts of things. I'm checking database stuff, but I hit the website and it comes up just fine. I'm like, what do you mean it's not broken? So the number one thing, they didn't even tell me it was just the search that was broken. They said the website is broken. So I was very furious about that. By the way, at this point, I'm starting my time tracking system going, I'm tracking my time for this and I'm billing them. Normally, I'm the guy who's like, okay, I'll help, not a big deal. But when you can't describe the issue on a Friday before the 4th of July, you're going to pay for that, right? Uptime matters, it's expensive. So I'm in there. We're running now we know what the problem is. We're testing search, it's not working. The DBA person, because this is a big organization, the developers can't touch the database, it's the DBA who has to do this, ran the script. I asked him, did you run the script? Yep, I ran the script, because we were doing something to tweak fields. And it still wasn't working. I went back, I looked at our ticket system, it says, yep, run the script. Here's a copy of the script. I looked at the script, and at the bottom of the script, it was rollback transaction. Because when we deliver a script to our clients, we want to make sure we don't accidentally just break it or run it on accident. So we always wrap it in a transaction, and there's always commit and rollback. And commit is always commented out. That's our policy. That's how we deploy SQL scripts to our customers. And the guy's on the phone literally saying, well, I saw it said like 40 rows changed. It must have ran. I'm like, did you actually commit the transaction? And we've worked with these guys for years. They know that this is the way we do things. And silence on the phone. And I'm like, how about we run it again and we uncommit rollback and we actually run it? So sure enough, that's what it was. So we had 3 of their team members on the phone. We had 2 people. We had a project manager, myself, and then eventually some other engineer jumped on. So we got 7 or 8 people on the Friday before 4th of July, all because somebody couldn't commit a transaction to the database. So we ran. And that's where I believe some of this really helps us. So also why I believe SQL is still a challenge to work with. But I hope you don't have to do stuff like that on the 4th of July. We did charge them a boatload of money for that incident, by the way.
$600 a minute.
Not quite. Maybe I should have. Not quite. So lots of positives and benefits. There are some cons, right? We've kind of alluded to them already. Cost. This stuff can get expensive is the short way to say it, right? You're doing all these things. It can be expensive. We can start getting into security issues with things not being open. Sometimes you want to lock down, especially in this work from home world, being able to hit all these resources from an outside IP is sometimes a challenge. There's a big one, and this is the one reason I still think that IaaS still has a place. If you have a tight on-premise integration to some system, it can become difficult because you're using all these resources and they're moving from region to region, wherever. It could be an issue. So it's not for everyone because of other things. And then dealing with SQL replication, as I've talked about. However, my main point is that Azure for high availability is totally worth it if you need it. I'm a big fan of the approach, especially with Azure App Services, and it can hopefully save you some headache on the 4th of July weekend. But really, that is what I had for everybody. One small favor, if you like my stuff and you want to learn more about Azure Static Web Apps, that QR code right there is to my podcast YouTube channel. And I'd love to get a couple more subscribers for that, or follow me on Twitter at McKeiver. I do talk about headless CMS, traditional CMS. I talk about Azure. There's a couple of tips on my blog, so I would love it to gain some subscribers today. In fact, I started the podcast with that guy in the back of the room, and we're going to do an episode after this session.